Let's take a look at this example to see how we can actually use iterators. In this example, I have a vector of strings called names, and let's say that I've somehow populated it with these three strings, Nima, Ryan, and Felix. I can iterate over this using an actual iterator by creating an iterator that points to the beginning. So iter is my iterator pointing to whatever my current element is, and by using the .begin method of the vector class, I get an iterator that is initially referencing the beginning. I'm using abstract terms like referencing, pointing to, because it's not actually pointing to this, but somehow it knows that it is representing the first item. So in reality, this iterator object, it's got some way of keeping track of the current element, which in this case, it's keeping track of the index of the current element. So right now, its current index, which is an int, is 0. It's looking at index 0. We also get an end iterator. So this one, begin, it basically represents the first item, whereas end, again, another method in the vector string class, or in the vector class, it represents the end, which is actually just after the last item. So begin represents the beginning, which is the first item, whereas end represents the end of this collection, which is just after the last item. So then I have a while loop. So actually, let's draw what end would look like. In this example, so let's say this is end, and I have, it's an iterator, so it also has some current indicator. But just after the last element is at index 2, so this would have index 3. And again, this is a vector string iterator. So while iterator is not equal to end, this I would have an overloaded inequality operator that in this case would check the current variable. 0 is not equal to 3, so my condition is true. I enter. I dereference my iterator. Again, iterator, it's not an actual pointer, it's its own class. So I've overloaded the dereference operator to return whatever the corresponding current element is. So for the case of this vector-based iterator, it would just return the item in my vector at index 0. So it'll return Nima. So this would print Nima. And then plus plus iterator. I'm incrementing my iterator. Again, it's not an actual pointer. So this is also overloaded. I've overloaded my pre-increment operator to go to whatever the next element is. So for the case of this vector-based iterator, where current is being represented using an int to represent the index, I would just increment the index. So now the current index is 1. While iter is not equal to n, so again, 1 is not equal to 3, I enter. Dereference my iterator, so I get the item at index 1, which is Ryan. Then increment my iterator. It's overloaded to just increment my current index. They're not equal. Dereference, so get the value at index 2, which is Felix. Increment. Now iter, which has a current index of 3, is equal to end, so my loop terminates. Let's take a look at this example of using iterators with a linked list. It's extremely similar to our previous example of using an iterator with a vector, and as you can see, the code is pretty much identical. The only exception is I'm using a linked list instead of a vector, but otherwise everything else is completely identical. But as you can see behind the scenes, the actual structure of the data is quite different. So first of all, we have a linked list, which, as you should recall, is a series of linked nodes. I have a head pointer, so this would be a node pointer pointing to the first node. Each node has a next pointer, which points to the next node. Otherwise, it'll be null. So this X refers to null. It's a null pointer. It's not pointing to anything. And then tail points to the last node. This is an example of a singly linked list. So I only have next pointers. I don't have previous pointers. So using the exact same code from the user perspective, I can get the exact same functionality as with the vector as long as I'm implementing my linked list iterator appropriately. So in the previous example, our iterator object had some current index. It was an index because the data structure was a vector, and we access elements via indices. In this example, my iterator object will have a node pointer pointing to the current node. So let's see what happens. I start by creating a linked list, populating it with names. In this example, Nima, Ryan, and Felix. This is the same list as the previous example, just as a linked list instead of a vector. Then I get an iterator to the beginning of my list. So my iterator has a current pointer, a node pointer, that points to the head node, the first node in my list. Then I get an end iterator using the end method. And this end method will return an iterator pointing to just after my last element. So let's see what it'll look like. I'm going to call it end. It's also an iterator, so it also has a cur pointer, node pointer, but pointing past the last element. What's after the last element? Null. So it'll have a null pointer inside of it. Let's take a look at my loop. So again, the code of my loop itself is 100% identical. I did not change anything in any of my code with the exception of changing vector to linked list. So this is totally identical. So my condition, while iter not equal to end, I would have overloaded the inequality operator such that it returns true if these two have different node pointers. So an iterator object, its equality is with respect to its current node pointer in the example of an iterator for a linked list. So this current pointer is not null. This current pointer is null. Therefore, these are not equal iterators. Therefore, this is true. I enter my loop. I dereference my iterator. Again, this would be an overloaded dereferencing operator because iter is not a node pointer. Iter is an iterator that contains a node pointer. I've dereferenced my iterator, and within it, I would have overloaded this to return the dereferenced cur pointer's data value. So the overloaded dereference operator here would return something like, it would be return cur dereference data. So whatever my cur pointer is, dereference it, return that node object's data value. And I print it, so this would print Nima. And then I increment, again, this is overloaded. So this would be overloaded. So maybe I'll take note of these. So this would be my dereference operator. Would look like this. My my increment operator would be overloaded to be something like this. Okay, let's see. So iterator, if I increment it, needs to point to the next item. So if I'm talking about a node pointer, it should point to the next node. So this would be something like cur equals cur next. So cur equals cur next. So what will happen? I will update this pointer to point to this object now. I go through the loop. Now this pointer is pointing to this node. End is pointing to null. So this is true. They are not equal. Dereference. So again, I overloaded my dereference operator to return cur arrow data, and I print it. So this prints Ryan. And then I increment my iterator, which I overloaded to update cur to now point to cur next. So cur equals cur dereference it next, which is pointing to this object. So I would update cur to now point to this object here. Next iteration of my loop. Iter not equal to end. Iter is pointing to this. So iter's cur is pointing to this object. End's cur is null. These are different curs. Therefore, they are unequal iterators. Enter my loop. Dereference iter's cur variable and get the data, which is Felix. Print it. Increment my iterator, which I've overloaded to set cur equal to cur next. So cur equals cur next, which is null. Therefore, I've set cur to be null. Next iteration, iter not equal to end. Iter, it has a cur pointer that is null. End has a cur pointer that is null. These are equal. Therefore, this is false. I terminate my loop. This got a little bit more complicated, but the key thing to remember is that by doing a little bit more work behind the scenes as the developer, so by creating this iterator class that had these overloaded methods, I was able to iterate over a linked list in the exact same manner as I was able to iterate over the vector, even though behind the scenes the data are organized in completely different ways. So by doing this, I've allowed the user to iterate over my collection in a completely uniform way as they would any other collection, regardless of how the data were organized.